Hello, sir. Our project name is uh, E-commerce Product Demand and Sales Analysis, and I'm Nitya Trishla, and my teammates are Chandana Priya and Tejaswini. Since our project is based on e-commerce, so we have taken three data set based on that um, category, which is customer interaction, product details, and transaction details. In this Azure storage container, we have created four containers: bronze layer, gold layer, silver layer, and raw data. In this raw data container, we have all those three CSV files. So for the first layer, which is bronze layer, we're just gonna ingest the data. For this, we have used Azure Data Factory to make the copy activity. So basically, we did like copy the data from raw layer to the bronze layer. For that, we just created the how that file's gonna be, and selected the wildcard file path so that all the three files will be copied all at once. And in sync part, we have said like it should be copied as the CSV file as well. And we have also selected the bronze layer file path from the Azure storage. This automatically copies the files in the raw data to the bronze layer. The first part of ingestion is done. And coming to the coding part, and starting with the silver layer, just a second. So at first we are obviously starting with the Spark session, and for the second step we're gonna mount the Azure storage. We're gonna access that storage. This is the container name. This is the container name, and this is the storage account name. And we also copied and pasted the access key of our storage container, storage account. And after mounting it, we gonna able to access those CSV files, and we are reading it into a data frame. And as always, as the exploration part, we are printing the schema, displaying the tables, all that stuff. And as we can see from the schema, all the columns are having a space in between the names, so which will not be a standardized one. So instead of the space, we're gonna replace it with underscore. This is the code for that. And then mm we're gonna join all the three files. So first we are joining two files, which are the products dataset and the customer dataset. For both the dataset, there is one common column, which is product ID. Making it as a reference and joining it. And and after combining those two columns, we are combining the third column, which is the transaction data set. For that transaction data set, the common column between the joint data set and the transaction data set is the order ID. So we are making it as a reference and joining those data sets. So we have combined all the three data sets as one. Now, as a part of cleansing, we are doing checking the null value. And as always, yes, there is null value in the dataset. So first we are dropping some of the columns which does not do any work in the dataset, and checking if there are null values. Yes, there are null values, and we are using drop now, which is dropping all the null values. After using this function, when we check if there are any null values, there will be nothing, as we can see. So all the null values from the dataset have been removed. Now we are if there are any duplicates in the dataset, that gonna affect the model that we're gonna train. So we're gonna drop the duplicates in the dataset, so the data is free from null values and duplicate values. And finally printing the schema. And as we can see from the column, just a second. In the price column, we have something like INR, which is Indian rupee. While computing, the price is actually a numeric value. When we combine it with INR, the system gonna collapse. Just to make sure that it does not do such things, so we're gonna remove that INR from the price column. So we are using this. and and then we are in the data set, we're gonna add two new columns named quantity and price. And for the quantity, the data type is going to be the integer, and for the price, the data type is going to be double. And along with that, we're gonna add another column named total sales. This total sales is will be the result of the multiplication of quantity and price. And now we are counting the category. Category is nothing but the products that has been shown in the dataset. So which are groceries, electronics, clothing, books, toys, like that, and their counts are being displayed. After that, we're gonna uh, as we know that these categories are in string type, right? So to make sure the computer understands more, so we're gonna make this as a numeric thing. So for that, as we can see in this area, there are 5 columns that has been added extra, that is electronics, clothing, groceries, books and toys. And if that product lies under any of these categories, that value should be 1. Like for example, in product 9, it comes under the category of toys, so that part comes 1. Like that, this will compute. After that, we're going to do the window function. Window function is basically a feature engineering process where window function basically helps for row level transformation like sorting, grouping, and here we are focusing on lag. Lag is basically we are creating a new column that holds the value of previous row. That's basically it. And there are many other window functions that can be used, but now we are here using lag. So what this describes, like for one day it says 1, and for 1 week there are 7 days, so it says 7, and for 1 month it's 30 days, so it says 30. And we are ordering the window function by the date of purchase. And as we can see, the column has been added as lag 1 day, lag 1 week and lag 1 month. It's like a record, and all the cleansing and transformation work is done. So we can mount the silver layer. I mean we are accessing the silver layer from the Azure storage, and we're gonna write the data frame as a Parquet file into the silver layer. So it will be stored as a Parquet file there. Parquet file will be more optimized and efficient to use. So that's about silver layer. So going on to gold layer. So gold layer, as usual, gold layer is basically for the training, testing the model and everything. So gold layer, for first we are as usual creating the Spark session, and we just return the Parquet file in the silver layer storage container, right? So we are accessing that layer here, and we are just printing. This is just to check if that Parquet file is accessible or not. And here we coming to linear regression. Linear regression is basically a supervised machine learning model. So it basically predicts the numerical target. And vector assembler. Vector assembler is mostly said to be a feature transformer. It is used by linear regression, of course, because this needs, like linear regression needs input features in the form of a single column. So what vector assembler do? This will combine 4 or 5 columns into a single column and give it to linear regression. As we can see, at the end, the features have been added as a single column. And here we are fitting and transforming the model. So the LR model fit is basically the trained regression model, and this model is applied to the input data frame. So this automatically adds a new column named prediction to the input data frame, as we can see here. And then we are calculating computation using regression evaluator. Regression evaluator basically helps to evaluate different computation like root mean square error, R square, and mean absolute error. So here we are basically giving the input column, output column, and the metric name. So root mean square error basically measures the standard deviation of the predicted value and the actual value, and the MSE actually computes the average of square difference of predicted value and actual value, and R square basically tells how well the regression fits the data, and MAE computes the average of absolute difference between prediction and actual data. And here are the results. And then we are here creating a new column named demand. So this demand is basically created so that we can categorize the product between high demand and low demand. So we basically set the demand as 4.5. So anything below 4.5 is low demand, and anything above 4.5 will be high demand. As you can see, the demand column has been added. And here we are using logistic regression. Logistic regression is used for binary classification and multi classification as well. So here we are giving the input column and the output column, and we are basically doing the fit and transform. And in this code we are splitting the dataset into training dataset and testing dataset as 70% and 30%. And as always, what we have done in linear regression, we are doing this in logistic regression as well. And we are saving that transform data as predictions too. And binary classification finds the ROC curve, and multi-classification can compute accuracy, precision, recall, like that. So here's the confusion matrix of the prediction, and after doing all the things, we're gonna mount this mount the goal layer, and write these files in a Parquet mode into the goal layer, so it automatically will be written in the Parquet file. Yeah, so now we're gonna for this much I have explained in Databricks Community Edition, because I'm gonna run the Azure Databricks files through Azure Data Factory. So I just explained here so that the output will be visible there. So here all the files have been here. So first I'm gonna we have the compute. One second. I'm just gonna reduce the inactivity time so that, yeah. Now going to the Azure Data Factory. Here we're gonna sequentially execute those three notebooks. Like first the silver layer notebook will be executed, and then the gold layer, like that. So here, let me start from the scratch. So here's the copy data that we have done for the first step. Here I'm just gonna drag and drop three notebooks since we are using Azure Databricks. Done. So I'm just gonna link this. So this is called sequential execution. Now we're gonna do all the parts. So first, notebook, let me rename it as silver layer, and notebook 2 as gold, gold, and notebook 3 as visualization. Done. So for the first layer, I've already created a link service as Azure Databricks automation, which contains access tokens, my clusters that I've already created, and my subscription that I've selected, and everything. So I'm gonna and then I'm gonna browse the notebook path here. So in users, I'm just gonna select the silver layer, and for the gold layer, the same process, selecting the link service, browsing the path of the gold layer notebook. And have also a file for visualization, which is just a dashboard thing, so I didn't explain that much. This is taking a lot of time. That's it. So just gonna publish the work. So pipeline is project 2, which is I renamed it as project 2, and I'm just gonna publish it. As we can see that this pipeline is publishing. After it says completed the publishing, we're gonna add the trigger. Yeah, it's completed. So now I'm gonna add the trigger now, and I'm gonna just click OK. Now as it says it's running, let's go to the monitor, and as we can see for the time, this manual trigger is running in progress, and we can go to the Azure Databricks and see the job runs. And let me reload the file. Just a second, it will update here that pipeline is running. See that this pipeline is running. We should wait a bit more time so that all the notebooks will be sequentially executed through Azure Data Factory. So these are all the files that I have succeeded at some notebook and failed in some notebook due to some mount errors like that. So yeah. So actually the first silver layer notebook takes the lot of time, like 2 minutes 5 seconds, and other notebooks are like 16 seconds and 33 seconds. Yeah. As we can see, the silver layer file is succeeded. So when we go to the Azure container and see the silver layer, we can actually see the Parquet file that is combined here. See, that is being updated at the same data timestamp. And the next, and those two files are being run at the same time, because in Azure Data Factory, what we did is we just at the same time we have connected those two, so they are running at the same time frame, and one notebook is succeeded. I think that would be the visualization part, and the goal layer is running. So for the goal layer it should update. Yeah, so here we are getting all the output files and all combined files and everything, and this gonna succeed and in the pipeline trigger. So as we can see, the outputs are being updated one by one. Yeah, so those three notebooks are successfully run through pipeline. So yeah, that's the project. Thank you, sir. In continuation with the project, this part focuses on the CI/CD pipeline in Azure DevOps. So, what CI/CD, which is continuous integration and continuous deployment, is gonna do? It basically automates the process of like testing, integrating, deploying code in for the developers to be stored in various environments efficiently. So here first I have created a repository named project 2, and I have created two branches apart from the main branch, which is development branch and production branch. So development branch is the branch where I deploy my code, and production branch and main branch are the branch which is the final deployed code, so a final approved code, we may say that. So first, I've already connected the Databricks to the Azure DevOps. So as we can see here, um, and what I'm gonna do is I'm gonna just move my files, which is here, move these three files, that is the gold layer, production visualization, silver layer, move this to my project 2 repository, move. So I've moved this and I've moved it in dev branch. So what I'm gonna do is I'm gonna pull this. Pull. So after pulling this request in Azure DevOps, it will let me refresh it. It will ask a pull request for main branch since it has pulled in a development branch. Development main, create, complete. I'm not gonna delete the development branch. So yeah, it's completed. So when we see the main branch, all the files will be there also. So uh, what I'm gonna do is I'm gonna create a YAML file to automate the process of CI/CD. So here I'm gonna create a folder named release. So whatever I'm deploying in main branch or development branch, it should automatically updated in release branch also, and I want to automatically deploy it in production branch also. So let me create this folder first. Folder release, create. So I have a release folder here. Now what I'm gonna do is I'm gonna create a pipeline. First let me give the variable group. I can't come out of that. Dave, this is just a second. We have Databricks host and Databricks token. So Databricks host name is nothing but this. And Databricks token this is the Databricks token. So I'm gonna save it. This is my variable group. Now I'm gonna create a pipeline. Create pipeline. Let me check it again. It's there. I'm just gonna copy my already file here. I'm gonna save. First let me check few credentials like save. I'm just gonna save it. I'll run that later on. Let me check in production branch. I'm gonna check some branch securities, like these should be allowed while, because I am trying to automate the deployment in production branch also, so this should be allowed defaultly. Allow. Okay, then okay, now I'm gonna run this pipeline. Run pipeline. Run. So it started running. As we can see, now it will ask a permission for our variable group, so we can permit that. And now it will be start running. Yeah, it started. As we can see, there is a artifact that has been published, which is all these files. Now we can go back and check the job runs. It's still running. It hardly take a couple of minutes. Yeah, the job is done. Now let's check the release folder here. I'm gonna reload this. Oh my gosh. As we can see, all the files are here in release folder, and we can also see the product branch to see if there's all the files have been pushed in product branch. See, all the files are there, which like in the main branch. So yeah, our YAML file has been run successfully. So what we're gonna do now is we're gonna create this pipeline in Data Factory through that release folder we have created. So whenever when a developer is creating a document or code, it will automatically deploy to the release folder, so we can automatically run through Azure Data Factory. So let me change few of the browsing paths. Like in this, should select the release folder, release silver layer, and for gold layer as well. And for the visualization part as well. So yeah, everything's done. Now we're gonna publish it and uh, add the trigger, and that's it. That's how this works. We have created a CI/CD pipeline and took that notebook and automating the execution. So the publishing is complete. So we're gonna add the trigger. Trigger now. Okay. It's in progress. As we can see now, let me check the job runs. As we can see that it's running, so our project is successful. As we already did this Azure Data Factory pipeline, so it will obviously gonna succeed all the three notebooks. So I'm gonna skip checking that. It will take a lot of time. And yeah, that's it. Thank you, sir.